Yes, thank you so much, Rob, and thank you to all of our presenters, Blaine, Bob, and Jay, and Rob also. Uh, we normally do this in the beginning, but I kind of wanted to make sure all the speakers had adequate time, but I didn't really get to kind of give you a full introduction, and so I was going to spend 2 minutes doing that, and we can go ahead and start going through the question pod. Um, for all of you on the webinar today, if you have questions, start typing them in. You'll see it over here, and you'll see that Bob has already responded. So I just want to remind everyone that this webinar is part of the Connected Fleet Challenge webinar series that's actually put together by the Cooperative Automated Transportation Coalition, or CAT Coalition, that brings together a lot of the folks from AASHTO, IT, ITS America, and OEMs, and a lot of our partners. And one thing that I think Blaine mentioned, but just to make it kind of clear, the whole challenge of the Connected Fleet Challenge is to equip at least one light-duty vehicle and one heavy-duty vehicle by 2021, and to start getting that feel for what it means when you start having vehicles on the roadway, communicating with your RSUs, and how that works. You heard generally some really good lessons learned about what Bob and the New York pilot is getting into, and just kind of the complexities that go into it. You heard from Jay about when we start doing it, we think it's correct, but what does the vehicle see? What does that mean for the onboard applications? And making sure we're testing that to understand the ins and outs. And then we also heard from Rob just a few minutes ago, talking about when you are looking at a mass deployment, more than one vehicle, what do you have to take into consideration? How do you take that in? And just understanding all the actual implementation complexities, and even testing and verification that go with it. So I encourage all of you to put in some questions. I'm just gonna read off. There was one question that came in, so and it was answered, but I'm gonna go ahead and just read that off for the purpose of those that may be following just on the phone. It was a question for Bob Roush, but which SAE standard are you using to specify allowable power consumption of the OBU within the host vehicle? And the answer to that is actually the SAE standard J3005-2014. 3005-2014, and it permits the device to draw up to 100 microamps with the ignition switch off. And so the folks in New York with their pilot settled for 25 microamps for the OBU, but it's getting into this level of detail when we're looking at connecting our fleets. So, yes, go ahead, Bob.
Yeah, actually, it's a little more complicated than that. I didn't have time to go through some of that, but it turns out that because of the way things work, and the amount of things that may be going on, we have a two-step power down. The ignition switch goes off, but the unit doesn't necessarily stop. They have some power step down, so that if it's in the middle of downloading or uploading, it can continue for several minutes before it finally shuts down to a 25 microamp quiescent current, with a requirement for a sledgehammer that shuts it down no matter what after a few minutes. But it was because a lot of things can happen. Or you're getting into the barn and they shut the ignition off, and we're trying to upload, and we're in the middle of an upload process. We sort of had to follow that line of reasoning.
Oh, that's a great bit of insight, Bob. And yeah, I think most of us probably were like, oh, we didn't even think about that. So thank you for that.
Another thing that I like that let me see, Rob mentioned was mobilization of the logistics involved in getting the vehicles to be installed. And we're at 800. We're going to thousands. And the problem is that getting the vehicles to the place where it can be installed is a pretty complex thing when you're trying to do this in Manhattan and Queens. And don't underestimate it. As a matter of fact, we've had to outfit a portable crew that goes out with a RSU, a pile of OBUs, and a GPS repeater and so forth, so they can actually set up the vehicles in their shop. We have an experienced crew that does that to expedite. We're indoor shops. We're not trying to set up Quonset huts, but it does work.
Yeah, and I think those are just additional considerations, especially for the infrastructure owner-operators when you are looking at, how do you get your entire fleet connected. Similar to that, there's a question that just came in from Jason Osaki. If your vehicles use a fleet management system that uses the OBD2 port, how's your OBU accessing the CAN bus? And I think this one, we might be able to get each of the speakers to answer because they've had different experiences, and I know Blaine's been working with the transit agency talking about buses, but how about we go Bob, Rob, Blaine, and then Jay? So Bob, maybe your experience first as far as the OBU is and how it's accessing the CAN bus.
Now that's a good question, because we started going to go straight into the OBD2 port, and by bifurcating and splitting the OBD2 port plus the OBD2 port actually requires that you go on the bus to ask for the PID you want. Instead, we don't interface using the OBD2 port. We go straight to the passive device I showed that actually runs the wires through this device for the CAN bus. Yeah, you have to find it and separate the wires, but it's a completely passive pickup. All we can do, unfortunately, is watch what goes flying by, but we get it inside or closer to the vehicle, so we get more accurate speed, because the signals don't all appear on the OBD2 port. And we're getting signals that are faster for our speed. We don't electrically interfere, and we don't have the problem that you stated in that situation, obviously.
Yeah, and then Rob, you guys over with your kind of equipping those fleets in Colorado, and I think as you start in Utah, what's been your experience?
Yeah, I think Bob described it pretty well. The OBD2 port has its own challenges, not only for existing devices that may be plugged in there, but also on many vehicles, the data that we're after is filtered before it gets there. So accessing that data behind that port, a little further toward the electronic control units in the vehicle is really critical to gain access to the data that we're looking for in a way that's reliable and accurate. So we use a custom cabling solution that lets us tap into that, again, behind the OBD2 port for permanent installation, allowing for that existing or future equipment that might be installed by the DOT to still occupy that OBD2 port.
Yeah, these are great points and from a good question. Blaine, I don't know if you have the answer to this because it's a little bit very detailed, and I know the vehicles you're working with are through the Utah Transit Agency, but any thoughts or do you have any insight into this and how they've handled it for buses?
So we've equipped buses and snowplows with onboard units, but we have not connected into the CAN bus system on either of those vehicles. So on the snowplow, all we're doing is connecting to the Force America system that runs the spreader and the plow. On the buses, we're connecting to an onboard computer system that's part of the transit agency's fleet management system, simply to find out whether the bus is behind schedule or not. So we're gathering the portions of the BSM data that we're broadcasting. We're just getting off of the GPS system, just bus location and direction and speed. We're not tapping into the vehicle systems at all. So our onboard connections
that's an interesting point too. Is
fairly immature, I guess, is probably a good statement.
Yeah.
From our experience, the OEMs are less than cooperative with trying to help you out here. They don't want you tapping back there, and I don't blame them. And the lessons learned are pretty significant. If you touch the CAN bus, be damn sure you disconnect that battery. We actually had some problems with some cars because we didn't. And all you do is touch that CAN bus, and you can actually corrupt some of the processing units they have on board. It just is. It's not set up, or the whole scheme. Maybe someday we'll see it that there's some minimal amount of data that's made available through some port. But right now, that's not the case.
Yeah. Jay, I was wondering if you had any insights from kind of what you work with a lot with the OEMs, but on this particular question.
Right. So first of all, from our application requirements point of view, we need CAN bus data from vehicle. Particularly when you talk about red light violation warning, we need to know the brake information, the speed information, the turn signal information, and so forth. So these are vehicle dynamics are primarily required for all the onboard applications to work as intended, and need those data in a quick and fast manner. So what we have been doing as a part of the CAMP, which is a consortium of multiple OEMs, we do not want to know other OEMs' secret about how their CAN operates. So what we have developed here is called a Netway Gateway Box, which is an interface between an OEM CAN interface, and this Netway Box converts that information to a common CAN definition that we developed here at CAMP. And we use OBU supplier, Denso. They support both the slow speed and high speed CAN, single wire and dual wire CAN interface. So we use that interface to connect that Netway gateway box that connects to the OBU. So now OBU can get all the programmed CAN data through the common definitions, and that's how we implement our applications for the need of CAN information for testing and verification.
Is that Denso box available to non-CAMP or others?
I believe so. I believe so. You can get that, and they have gone through several revisions, but each one of them they do provide a CAN interface.
I also point out that when we've been going the different vehicle type, the different make and model years, man, they can be radically different changes in the data you have to pick up from the CAN bus.
Yeah, Bob, thanks for bringing that up. I was just going to echo that as well. That is definitely a challenge I referenced a little bit in my deck. The data available changes make, model year, trim, and mid-year changes among the OEM vehicle updates. So that can present challenges for getting access to data on light vehicles. That being said, it's also worth pointing out, though, that heavy vehicles have a different system in place, and in many ways it's easier to connect with and easier to find data elements because it's less of an OEM secret and more of a standardized communications infrastructure. So if you are looking to do that one heavy fleet vehicle, that actually might be a bit easier in order to get access to data.
Yeah. We've had pretty good access with the buses as well, because we're outfitting about 600, 700 buses, and that's been working well for us.
Wonderful.
So from the CAMP's perspective, we not only grab the data from the CAN bus from our applications, but what the application generates as an output also goes back to the CAN bus, so that individual OEM can display that information in the instrument cluster, for example, and they can create a different user interface or HMI depending on how they want to do that. So the reason for us to very tightly couple with the CAN is very important.
Those are some very great and detailed and in-depth answers. Just speak to the knowledge that's available on our with our presenters. So thank you for that. I haven't seen any questions come through, so I'll give a little bit of a plug. But then, if you have any dying questions or burning questions, not dying, I hope no one's dying. Burning questions that you want to ask the speakers, please do. I would just like to mention that we are going to be able to post a recording along with slides and speaker bios and information on our website, not only with on the Connected Fleet Challenge web pages, but also on our normal on-demand section of our website also. The links, in case you're wondering, are in the useful links box right under Jay's awesome picture. And I will hold tight for about 2-3 minutes and see if anyone has any other questions they want to ask, and ask the speakers to stand by. I usually don't prepare any jokes, so unless the speakers want to chime in with a joke, but we still have a couple minutes, and I didn't want to negate anyone the opportunity.
If you,
Or Bob, sure.
Yeah, there's a lot of stuff that I have on my slides that I didn't discuss, but you heard the others talk about considerations for over-the-air updates. Whatever you're going to put out there in your vehicles, you need to make sure you have a reasonably easy way to update their firmware. I guarantee that the first time you put it in the vehicle, it's not going to probably do what you all wanted it to do the way you wanted it to do it. So you need to make sure you have the ability to, I'll call it tune. Some people would call it fix. Other people would call it enhance. It doesn't matter. You just need a way to be able to change it.
Excellent. Looks like we're not getting any other questions. So with that, I hope no one will mind if we end about 5 minutes earlier, but I wanted to thank let me double check one more thing. Blaine, are there any other announcements or closing remarks that you wanted to make in regards to, on behalf of the CAT Coalition and just kind of this whole webinar series?
Only just to thank the three speakers for some really insightful knowledge and discussion about connecting vehicles. Really appreciate that. We learned from that. And thank everybody for participating today. This was great.
Yeah, and especially from me, I just wanted to thank everyone for attending, and just continuing the effort that we have to transfer our knowledge and learn from each other, so that we deploy faster and faster. But thank you for attending, and on behalf of the National Operations Center of Excellence, the CAT Coalition, and all of our presenters, have a great rest of your day. Thank you, everyone.
Thank you.